This is AP Physics video number 2. Also standing in today is my cat over here. This is to prove that the cat fur that I use for this lesson does not come from my cat, because you can see clearly that my cat is gray and the fur is white. Okay, so just to review what we had the other day, roughly the charge that we put on the balloons, the two latex balloons, was about 1 × 10⁻⁸ coulombs. So I want to show you roughly how many electrons that is. Just doing a little conversion between electrons and coulombs gives me about 6.24 × 10⁻⁻ electrons. So what that means is that in the interaction between rubbing of my shirt on the balloon, there was about that many electrons transferred, in this case from my shirt to the balloon. So roughly that many electrons. It may seem like a lot of electrons, but in proportion to how many there are in total, it's actually a pretty small number that would be on the balloon that are actually transferred to it versus how many were there already. Anyway, some things, other things you should know. Again, 3 videos that are related to this first lesson. One's a tape trick you should have seen already and commented on that at your leisure. Number 1, though, you were supposed to comment on, or you should comment on it during the actual class time that you have class. That's on Tuesday or Wednesday, depending on which section you're in. And make sure you do that during class time. That's my mean of taking attendance for that. And then finally, this video, more of this focuses on the idea of what happens with conductive balloons in electrostatic situations. So that's what's going on. And now I'm going to turn things around just a little bit so you can see what I'm doing over here. So now I'm going to charge up the rod with the fur here. And again, it's just like what I did with my shirt the other day. What I'm doing is I'm transferring electrons from the fur now to the plastic rod. And you can probably guess correctly what's going to happen when I hold this close to the balloon. So it's attracted to it, right? And now it stopped being attracted to it. Make sure I got it all charged up. Now it looks like there was probably not quite 100% transfer of charge between the rod and the balloon, because there was a little bit of still attraction going on here. So I'm trying to make sure that I have the balloon all charged up. And now you can see clearly, I can push it all the way out of the screen now with my rod when I put it close to it. Here I go again. And I push it clearly out of the way. Okay? Now after a while it may lose some charge again. I may need to charge it up. But here's the thing that I really wanted you to notice about this today. Once I get this thing charged up, I got to be careful not to let it touch me. How come? Because what the extra electrons want to do that I put on that conductor is they want to leave it any way they can. Now some of them might want to try to go down this string, but that's not a very good conductor either, so it doesn't want to leave them very much that way. But if I get this thing all charged up and I don't give it any way to leave, and then I bring my finger over close, there was a tiny little pop there. I don't know if you could hear that, probably not. But there's a tiny little crack there because what happened was I gave all those electrons a chance to leave now, okay? So if I hold my hand up next to it now, there's basically no interaction at all. Unless maybe, I don't think there's any charge left on there at all. So what's the big thing to notice here is that with the rubber balloons, the latex balloons, if I charge them up and I come close to them, I can actually put my hand on it and I can actually pull it up. That's what I was talking about with the challenge on video number 1. And the charge basically stays on the balloon. It doesn't go to me much at all. And I'm able to actually move the balloon with my hand all the way up towards the ceiling. Yeah? With this one, once I get this all charged up, bang, charge goes away from it immediately because it's a conductor. So main difference here then, again, the conductor, it's also influenced by the rod for sure, right? I can influence the charges. I can create an induced charge on it, can create an attraction for it. And then once the charge goes onto it and I build up enough charge, then it's going to be repelled by the rod. And then once it's totally charged up and I don't give it any other way to leave, if I bring my finger over next to it, all that charge goes to me immediately, and that's why there's a little teeny spark.